All right, welcome back to The Explainer. Today we're diving into the Fixed Network series, specifically looking at OLT configurations and aggregation link fixes. Now, if you were with us for Phase 2, you know we explored that last mile right outside the customer's home. But today? Today we're moving on to Phase 3. We are traveling way deeper into the city's infrastructure to look at the heavy-duty tech that literally keeps entire districts online. Let's get right into it.
So think about this for a second. You've successfully connected a customer's home with pristine fiber optic cable, right? The light is pulsing, the router is blinking away, but where does all that neighborhood data actually go next? Every single click, every video stream, every email, it all has to leave the neighborhood somehow. Well, it travels back through those street cabinets and ultimately arrives at a place we call the central office.
Okay, let's dive into this. This brings us to what's known as the Metro and Aggregation Network. To picture this, just think of it like a massive regional train station. You've got thousands of individual fiber lines arriving from all these different neighborhoods, and this hub collects them, bundles them up, and puts them onto high-speed rail lines heading straight for the main internet backbone. It's essentially the ultimate sorting and forwarding hub for the entire city grid. Now, inside that central office, you're going to find racks upon racks of equipment, and they rely heavily on two absolutely crucial core components. First up is the OLT, or optical line terminal. This is a massive chassis that handles the super delicate light signals for literally thousands of fiber-to-the-home customers all at once. And right next to it, that's the aggregation switch. It takes all that organized data from multiple OLTs and channels it out through these massive uplink cards. This right here is exactly where advanced software configuration meets raw high-capacity hardware. But, hardware at this level can fail. And when it does, it's a huge deal. It doesn't just take down one house. We're talking about entire streets going dark. This brings us to our first major conflict, something we often call the network jammer. Out of nowhere, for seemingly absolutely no reason, an entire neighborhood just drops offline, and you've got red alarms flashing everywhere. Now, what's really interesting about this is the mechanics behind the outage. It almost always comes down to something called a rogue ONT. See, GPON technology requires all the customers connected to the same OLT port to actually share a single fiber strand. Because of that, they basically have to politely take turns transmitting their pulses of light. But if just one customer's home modem, their ONT, gets damaged, say by a power surge or just faulty electricity, it can lose its timing. It might start transmitting this solid, continuous beam of light. And guess what? That completely blinds the OLT port. It instantly knocks every other perfectly clean paying customer on that distribution fiber completely offline. Just like that, one single broken device ruins the shared connection for everyone. But here's the elegant part about troubleshooting this. You don't actually need a physical truck roll to go check every single house on the street. Instead, you just log directly into the OLT management software using the command line interface. Once you're in, you enable the built-in rogue detection. The system automatically does the heavy lifting. It analyzes the incoming light patterns to pinpoint the exact serial number of that broken device. From there, you just execute a remote deactivate command. That shuts down that specific faulty ONT port, the jamming signal drops, and boom, the rest of the neighborhood instantly comes back online. It's a real game changer. Okay, so that covers localized threats. But what happens when the issue isn't a broken device at all, but just sheer, overwhelming volume? Well, that leads us to our second massive hurdle, the city traffic jam. This typically rears its ugly head during evening peak hours. You know the drill. Right when an entire sector of the city logs on at the exact same time to stream movies, play games, or finish up work. And this brilliantly illustrates the danger. The big issue here is hitting 99% uplink port bandwidth utilization. The crazy thing is, the local fiber lines out in the streets are perfectly fine. The OLT itself, working flawlessly. But that main uplink card, that absolutely critical pipe connecting the OLT to the aggregation switch, it just runs out of capacity. When that pipe is completely full, data packets literally start crashing into each other. For the end user, this means severe latency, endless video buffering, and massive packet drops for an entire district of the city. So how do we fix this? We have to expand the data highway itself using a hybrid hardware and software approach. First, you physically install a new, higher capacity SFP module, like a 40 gigabit or even a massive 100 gigabit optical transceiver, right into an empty slot on the OLT uplink card. After you connect a fresh fiber patch cord over to the aggregation switch, the real magic happens in the software.
You configure a protocol called link aggregation, or LACP for short. This safely bonds the old port and the new port together so they act as one single massive team. Just like that, you've instantly doubled your bandwidth capacity and totally cleared the congestion.
So the crucial point here is that proactively managing this metro and aggregation network takes a mix of analytical thinking, software skills, and physical discipline to protect that data flow. Industry best practices mean keeping that rogue detection software active in the background all the time. You also need to monitor those uplink traffic graphs daily. You really want to spot that trend toward 99% capacity weeks before it actually happens. Oh, and whenever you're doing work in the central office, make sure all your fiber patch cords are neatly routed. This prevents physical microbends, which can seriously degrade the light signal before it even leaves the building. Precision absolutely matters here. All right, before we wrap up, let's tie together the most important concept we've explored today. I want you to think about this. When an entire branch of fiber-to-the-home customers suddenly goes offline because of a continuous, untimed light transmission coming from just one single faulty home device, what is that localized villain called? It's a rogue ONT, or a rogue ONU. Hunting down these rogue devices from the console and proactively expanding those uplink pipes before they saturate, well, these are absolutely crucial steps to protecting the data flow for thousands of citizens. In our next phase, we're actually going to leave the city entirely and connect these metro aggregation switches to the massive global internet core. So keep troubleshooting, keep exploring, and as our cities demand more and more data every single day, it leaves us with one final thought to ponder. What happens when even our bonded 100 gigabit highways become the new bottleneck? Thanks for joining me, and I'll see you in the next explainer.